Yesterday means the last lecture, uh, we discussed about capacitors and inductors. How capacitor and inductor behaves when they are attached to DC sources, what are their voltage current relationship, and all these things. And we had some examples also. So today we are going to start our discussion with first order circuits. So first order circuits are the circuits which are having first order differential equation. Okay, earlier if you remember, we were having only the resistor and voltage sources or current sources. All our equations were linear equations, so we used to call them linear circuits. Now we have first order differential equations, so we will call them first order circuits. Okay, so if you consider this RC combination, there is a series combination of resistor and capacitor. Some current will flow, it will charge, and these things you have seen that after some time this voltage will discharge, it will come here. How it will happen, all these things we have to see. And when we write those equations, KVL, using KVL or KCL, the equations that we get, they are in the form of first order differential equation. Okay, so let us say that both of them, they are in parallel to each other, and so both of them will have the same voltage, and that voltage at any time is Vt. Okay, now uh, since the initial voltage across capacitor was V naught, that is what we are saying, that initially this capacitor was charged and after that it is connected to a resistor. Tell us what will happen to the voltage across capacitor. So we said, okay, voltage across capacitor, initially it was V naught. So the initial energy stored in the capacitor is 1 by 2 C V naught square. Now look at this node. If I apply KCL, that means this current plus this current should be equal to 0. Okay, so current in capacitor plus current in resistor should be equal to 0. What is the current in capacitor? C dV by dt. And what is the current in resistor? V minus 0 by R. Okay, so these two are 0. So now I will take capacitor also this side. So dV by dt, V by CR is equal to 0. So now this is dV. So I will bring this V this side. So dV by V is equal to minus 1 by RC dt. And when you take log on both sides, so natural log of V is minus 1 by minus T by RC plus natural log of A. That is the constant. Okay. So these are the things that we get from very simple calculation, where A is our integration constant. Okay. When you solve this by integration, you get this as your constant. So that means natural log, this is natural log, this is natural log. So natural log of V by A is minus T by RC. And now when you take exponential both side, that means V by A, so one step is missing, V by A is e raised to power minus T by RC, or V is equal to A into e raised to power minus T by RC. So this is the equation that I get for voltage. Just a moment. हेलो हाँ जी हाँ जी बताइए कंट्रोल कंट्रोल ऑल्ट डिलीट चेक योर वाईफाई कनेक्शन press refresh button. Okay, control alt delete check your Wi-Fi. Okay, reconnect your Wi-Fi, press refresh button F5. If this thing works fine, otherwise restart the laptop. Don't click the submit button. Okay, don't click the submit test button. Don't finish the attempt. Okay, There is a reload button also.
Reload the current page.
Yes.
But I am out of the cell now, I think.
So
I am pressing control already.
so press cancel and go back to SEB and then refresh.
Yes, sir, now it's working. Thank you.
It was written in the FAQs. You don't read those things. Okay, sorry for the disturbance. Actually, the exams are going on and sometime I may have to help them. So this is the equation that we got, that voltage at any time t is A, which is a constant, into e raised to power minus t by RC. R is known to us, C is known to us, t is the time we may have to find A. Okay, and what is A? A is nothing but the initial condition, which is the initial value of this voltage, that is V naught. So that is our equation. And how did I get that? I will simply put t equal to 0. That means V of 0 is A times e raised to power. E raised to power 0 is 1. That means what is the value of A? A is the value of voltage at time t equal to 0. And what is that? V naught. That is how I got the value of A. Any problem to any student in this?
Sir, please show the circuit.
Huh?
Show the circuit me one time.
Okay. Okay, now.
Okay, sir.
So now if I look at this equation at t equal to 0, when I start plotting it, at t equal to 0, it is V naught, and slowly it will come. When I put t equal to infinity, it will be 0. Okay, this way it is slowly going down. This is also called the natural response. It is also called the transient response. Response means output. Okay, natural response or transient response means naturally what is happening. See, in the circuit, is there any voltage source attached or current source? There is no voltage source, there is no current source. So whatever is happening because of the initial conditions. Naturally the current is flowing, okay, and naturally some output values are being generated. Naturally we are not applying any external force. Force means voltage or current. So this is also called source free response. This is also called natural response or transient response. Okay, and this is the graph. And then we can do few things. Okay, put t equal to tau and find out where do I get V naught, V of t. So what I am doing, my equation is V naught is equal to V of t is equal to V naught e raised to power minus t by RC. If I put t equal to RC and I call that tau, okay, then e raised to power minus 1, that means V naught divided by E, and V naught divided by E is 0.368. That means at tau equal to RC, my V of t is 0.368 of V naught. That means I can say this is my time constant. And now if I make the observation at 2 tau, 3 tau and all, I can see how much voltage I will get. So if I put tau, 2 tau, 3 tau, 4 tau, 5 tau, so I can see how my voltage is decreasing and going very close to 0. Okay, so this tau is called time constant. Okay, time constant tau of a circuit is the time required for the response to decay by a factor of 1 by e from the initial value. And as we observed that this was the value at tau, 2 tau, 3 tau, 4 tau, 5 tau, and so on. So normally we can say at tau equal to, if the value of tau is high, that means it will decay slowly. If the value of tau is less, it will decay much faster. And tau is equal to RC. If you make this factor high, your decay time will be slower. It will take more time. If it is low value, it will immediately discharge. If you have a series combination of resistor and capacitor, sorry, parallel combination, can you discharge this capacitor immediately?
No, sir.
No. Anyone with yes?
If time constant is very low, then we can discharge it immediately.
Sir, here tau
Sir,
would be
sir,
0.
we can,
So
sir, we
yes.
can remove R. If you don't
You
use R,
replace R with short circuit.
yes, sir. Then it will,
Yes,
I
yes.
will go to infinity and everything will change instantly.
Hello? Hello?
Okay,
Hi.
student, please wait, please wait. Okay, so someone was saying something. Why are we replacing with short
Sir,
circuit and all?
sir,
See,
because
we
we
are
want, yeah.
if I replace the resistor with a short circuit, that means tau is equal to RC. R will be 0, so tau will be 0. Okay, that means this capacitor will discharge immediately. This is what we do whenever you deal with capacitors. The best thing is you take the capacitor and touch it to a metal wire or metal surface. So if there is any initial voltage stored in the capacitor, because if you keep this open circuit, capacitor will not discharge, right? Then at that time R is equal to infinity. It will not discharge. It will keep charged. So the best thing is take the capacitor and touch both the legs with a metal plate or metal surface. So it will immediately discharge. And then you use it. Okay. So now whenever we have to work with source free circuits, if we have looked at the equation is V of t is equal to V naught e raised to power minus t by tau. So in this equation, I have to find only two things, V naught and tau. Okay. So there are long ways of doing it, but this is the short method, and some of you have been using it maybe in class 11th or 12th. So I have this circuit. We are asking,
Sir,
yes,
we can short circuit the capacitor initially.
yes.
Okay.
Okay, now we are saying, okay, please mute your mic. Now we are saying the initial voltage across capacitor is 15 volt. Find Vc, Vx and Ix for t greater than 0. Okay. So Vx is the voltage across this 12 ohm, and there is 8 ohm, there is 5 ohm, this is Vc. If you look at the complete circuit, then you can say 8 plus 12 is 20. 20 is parallel to 5. That means effectively this circuit is 0.1 farad parallel with 4 ohm. Is it fine? Plus
Yes, sir.
minus Vc. Okay. So what is V naught?
15.
15. What is tau?
0.4.
0.4.
0.4.
0.1
0.4.
into 4. 0.4. So what is the equation of Vc of t? That is 0.4 e raised to power minus t by 0.4. Is this okay?
Sir, 15. It will be 15.
Sorry. 15. Is this fine?
Yes, sir.
Right.
Yes, sir.
Now tell me what will be Vx or Ix?
Sir, 8 by 20 into VC.
So Vx will be 8 by 20 of Vc of t. Any problem in this?
No, sir.
See,
No, sir.
this is Vc, which is across this capacitor. The same voltage is across 5 ohm. Same voltage is across 20 ohm. Same voltage is across 4 ohm. Is this okay to everyone? Now, if the voltage, sorry, this should be 12 by 20, not 8 by 20.
Yes,
So
sir.
what
We
will
have.
be the
12 by 20.
12 by? So what will be the voltage across only 12? That means 12 by 20 of total voltage. This is okay.
Yes,
Now
sir.
what will be Ix?
Vx upon 12.
So
Vx upon 12 or
we
Vc
see
by
by
20?
20.
Anyone? Is that fine?
Yes, sir.
Everyone is
Sir, I
fine with
didn't
this?
understand 12 upon 21.
Okay. So we are saying that the voltage across capacitor is Vc. This capacitor is parallel to 5 ohm, is parallel to this 20 ohm. Okay. That means voltage across 20 ohm is same as voltage across this capacitor. Just a moment. Hello. Anji.
हेलो सर मैं स्टूडेंट को मैथमेटिक्स बोल रही हूँ मेरा थोड़ा एक्शन चल रहा था तो अभी नेटवर्क चला था 5 मिनट
So no problem. Either you wait, Control Alt Delete, change your Wi-Fi, start hotspot, change your Wi-Fi with Control Alt
सर
Delete.
गूगल मीट भी चला गया उसकी वजह से
तो देखो, आप अपने इन्विजिलेटर या इंस्ट्रक्टर से बात करिए और एक्स्ट्रा टाइम वो दे सकते हैं, मैं नहीं। ठीक है,
इंस्ट्रक्टर का नंबर
इन्विजिलेटर से बात करिए, उनसे ले लीजिए।
सर गूगल मीट भी चला के नेटवर्क की वजह से
कौन सा कोर्स है? कौन सा कोर्स है?
सर l12
सौरभ सर है ना?
हाँ
10 मिनट बचे हैं।
सर 5 मिनट के लिए पूरा नेटवर्क चला गया गूगल मीट भी नहीं चलता ना वो चलता है
सौरभ सर का नंबर लिखो 97273
7
273 29454। ठीक है, सर से बात करो। हाँ जी, बताइए। Okay, students. So sorry. So uh, there are a set of students who will not follow the instruction when we send them, and then what can happen that they will miss the exam, and if they miss the exam, then you will miss the marks. Okay, so we'll tell you how to take the exams and all. Coming back to this question, we were stuck at the point that why it is 8 by 20. So this total resistance is, sorry, why it is 12 by 20. This total resistance is 20, and the voltage across 20 ohm, voltage across 20 ohm is VC. And in that 20 ohm, there is 8 and 12. So what will be the voltage across 12 ohm? 12 by 20 of VC. Is that fine?
Yes, sir.
Yes, sir.
Okay. So this is all same thing explained again. You can go through. This is a very simple question. Let us verbally solve it. So who is going to solve for me verbally?
Sir,
Okay, right. Start.
yeah, 12 and 6 ohm are in parallel.
Okay, they will make 4.
The 4. And then
Okay.
4 and 8 in series 12.
Okay. So total
So we will
resistance
get
is 12. Capacitor is 1 by
R is
3.
equal to 12.
That means RC
Yes,
is
sir.
12 into 1 by 3. That means 4.
4. Then
That means the,
VC at any time.
uh-huh.
Then
V
VC at
naught,
any time
V
t is
naught
equal
is
to V
30.
naught, that is 30 e to
Okay.
the power minus t upon 4.
Okay. So that is why V naught e raised to power t by 4. That means 0.25 t. Is
That
this
is
okay to everyone?
VC at any time.
So this is VC. Is it okay?
Yes, sir.
Now tell me how to calculate Vx.
Then Vx now, sir, Vx is that voltage across 6 ohm. That will be same voltage across 12 ohm.
Okay.
Both have same because both are in parallel.
Fine.
Then that is actually voltage across. They are both combination 4 ohm. So it
That
will
is
be
4
4
ohm.
upon 12.
Yes. So
4
that will
upon
be
12.
4 by 12 of VC.
Yes, sir.
Okay, that is why it is 1 by 3 of Vc and 10 into e raised to power. Is this also fine to everyone?
Yes, sir.
Yes, sir.
Yes, sir. Now, how to calculate I
Sir,
naught?
that will be
I
like
know.
VC upon
That will be Vc upon
4.
Tw- tw- 12.
12. So 12.
12,
12.
12
12. Sorry, 12.
total resistance, right? And with a minus sign because it is in the opposite direction. Okay,
Sir. Yes, sir.
right. So now we have this circuit. There is this figure given to us. We are saying there is a switch. This switch is initially closed for a very long time, and at t equal to 0 we will open this switch. Tell us what is the value of Vt at any given time. So when we give these type of circuits, when we have closed switch for a long time, that means we are considering infinite time. Infinite time means DC conditions. Under DC condition, this capacitor will be open circuit. Is this okay?
Yes, sir.
Yes, sir.
Yes, sir.
So what will be the voltage across capacitor at t equal to 0 or slightly below before t equal to 0?
Sir, 5.
So we can first
15.
find the
15.
current in the
15.
circuit and then
Open
It would be
circuit, this
same
one
as in across
15.
9 ohm.
as of 9 ohm.
Sir,
9
15.
by 12 of 20. Is this okay?
Yes, sir.
Yeah.
So this is the value of V naught. Is it fine? Now after that I am saying this switch is open. That means this much circuit is gone. So now I have one capacitor in series with, in parallel with these two. Okay. I am asking the voltage across here. So what is the value of R? 10 ohm. C is 20 millifarad. So
Sir,
you
mine
get,
point
huh?
2. Point 2.
So that is okay. That means my equation of Vt is 15 into e raised to power minus t by 0.2 or 15 e raised to power minus 5t. Is this okay?
Sir, can you please
Yes.
explain this R equal to 10 again?
R is equal to 10 because 1 ohm and 9 ohm they are in series and the combination is parallel to this resistance, this capacitor.
So you are neglecting that left hand side circuit, right?
Because this is open circuit. We are saying this is open now.
Okay,
So
okay.
this is open. That means these are gone.
Hmm.
Sir, why this is open?
We are saying that we are opening it. It is given in the question. Read the question. The switch is closed for a long time and it is open at t equal to 0. Okay. When you open this switch, that means you are disconnecting the voltage source.
Yes, sir. Understood.
Okay. So then we go ahead. This is all fine. These are all fine. After that, you can be asked that, okay, Vt is this and what is the energy stored, half CV square. You can calculate all those things. So a very similar question. Here we are saying that this switch was closed for a long time and we open it at t equal to 0. So now tell us what is V. So when the switch was closed, that means this is open circuit. So we will not consider this. And 4 and 12 will give you 3, 3 and 6 in series. So the voltage across 12 or voltage across 4 is 3 by 9 into 24. That means 8 volt. So initial voltage V naught is 8 volt. After we open this circuit, these two are removed. Now this capacitor and this 3 ohm, they are in parallel. So R is 1 by 6, C is equal to 3. That means RC is 1 by 2. That means my equation is V naught e raised to power minus t by tau. So 8 e raised to power minus 2t. Okay, so this one is also fine. We have solved it. Energy stored also we can find. Next, just like RC circuits, we can have parallel RL circuits also. In always remember one thing, whenever you deal with capacitor, your driving factor should be voltage. Okay. Whenever you deal with inductor, your driving factor should be current. Okay. So now I have one R and L. So what I say, okay, this inductor will have a voltage across inductor, this will have a voltage across resistor, and this much current is flowing. First of all, I will focus on how much is the initial current across the inductor, then I can calculate the other things. Okay, please see one thing very carefully here and don't think it's a mistake. I have taken the voltage across inductor like this, voltage across resistor like this. It is all my assumption. How do I take them? Okay, don't be worried or confused that both of them should be plus minus plus minus. I am measuring the voltage across inductor like this. I am measuring the voltage across resistor like this. That's all. When I apply KVL with current I, it is entering from plus side, so VR, you are able to hear me, right? Right. So this is VR plus VL. So VR plus VL equal to 0. And this is the current. So what is the value of VR? That is R into I. What is the value of VL? L di by dt. So I will repeat the same thing. di by dt plus r by l equal to 0, then I will bring this I on the other side, then I will integrate, and I get this equation. Exactly same process we have to follow. Okay, nothing different. So when I do that, I get the equation of it. It is I naught e raised to power minus t divided by L by R, or you can call it minus RT by L. So for the inductor, the time constant is L by R, and initial voltage or initial current is I naught. So again, we are at the same thing, that whenever I am going to deal with RL circuits, I will focus on two things: calculation of I naught and tau. I naught is the initial current and tau is L by R. Is this fine to everyone? Okay.
Yes, sir.
Just a moment. Just a moment. Okay, so really sorry. This is actually the first day of exam for students, and fine. Okay, so we have a question here. Now we are complicating the thing slightly. We have one inductor, we have one resistor, we have another resistor, and we have a voltage source which is 3 times I, and we are asking calculate I of t and Ix t. Okay. Now, one thing which is given to us, IT is 10 ampere. Okay. So till now we used to be very easy in our approach, that okay, I don't have to worry anything. I have to calculate I naught already given, and I will calculate L by R. L is given. What is R? Tell me, anyone who can tell me what is R in this case.
Sir, we will replace the battery with a short circuit and then we will calculate R, which is called as R effective.
It is a dependent. It is a dependent source. You cannot
Okay,
make
Sir,
it.
R
okay.
will be 4.
R will be 4.
Yes, sir.
Why?
Sir, because
0.75.
R will be 4.
0.75.
0.71y.
75 sir, 0.
Just a moment. हाँ हेलो, हाँ जी बताइए. हाँ जी.
सर मैं पाँच सौ बोल रहा हूँ.
प्रॉब्लम बताइए.
सर मैंने ये मेरा एसएससी का टेस्ट था ना, तो जैसे ही वो टेस्ट खत्म हुआ ना तो फीडबैक का लिंक नहीं आ रहा था.
तो एक बात बताओ, इंस्ट्रक्शन पढ़ी थी ना कि अगर फीडबैक नहीं आएगा तो क्या करना है.
सर वो एसएससी के सेक्शन में जाके, लेकिन मतलब सारे जो छोटे बोलते थे ये इक्वेशन करके है ना 1 मार्क का.
हाँ हाँ.
वो आ रहा है, तो सबने बोला कि वो खोलो, तो वो मैंने खोला है ना. ये 10 मिनट का है और इसमें एक मतलब मार्क 10 लिखा हुआ है और क्वेश्चन है, क्वेश्चन 1 है राइट इक्वेशन करके, और ये 1 मार्क का है. तो इसको क्या करूँ, फिनिश कर दूँ?
फिनिश करके फीडबैक लिंक मिलता है तो क्लिक करो, खत्म करो, नहीं तो पीसी को रिस्टार्ट करो.
Sir, hello.
ओके. यस
Sir,
यस यस.
we will
हाँ
take
बताइए.
ix equals to 2. Ix equals to 2i. Ix
ix equal to 2i. y.
because sir the dependent source is giving 3i and it
ठीक
gets
है.
divided and we have given that l is getting entered with I.
नहीं नहीं, देखिए. I current.
Sir, R equivalent to
This is
0.75.
this is by fine. This is 3i. I
So
is going
ix
here. एक सेकेंड. हेलो सर.
Ix will be 2i.
हाँ जी सर बताइए. हाँ
मैं
सर.
ये कह रहा था कि ना मैंने यहाँ एक बच्चों को मेल करा है और आने के लिए कॉलेज आए.
हाँ सर, वो मैंने देख लिया सर.
हाँ, वो मैं आपसे बात करना भूल जाता, तो बोला मैं बता देता हूँ.
नहीं.
यार बहुत दिन अपना प्रोजेक्ट इफेक्ट हुआ है यार.
ठीक है
मार्क्स
ठीक
में
है.
पैसे
हाँ
खत्म हो
उनको
जाएगा.
थोड़ा बोल देते हैं.
है ना, तो
अभी थोड़ा मैं वो लेक्चर ले रहा हूँ सर, फिर बात करते हैं इसका.
ओके ओके.
ओके. हाँ राइट. सो यू वर फाइन. You
yes
were
sir
fine that 3i is
ix
total. So this is I. The ix will be
ix
2i.
equals, so then the voltage across 2 will be equal to voltage across l, which will be l di by dt.
But sir, 3i, but sir, 3i is the voltage. It's not the current.
Who
हाँ.
said?
So thank you for correcting. Okay. So now you understand why it is not 2i.
Okay, okay, okay.
Okay. Now anyone with any other solution? Someone was saying I can take this register as 0.75.
Sir, I didn't understand why ix is not equals to I.
Why ix is not equal to I? That means this current and this current. Why should they be equal?
No, ix not equals to I.
Because this is not a current source. If it was a current source, then this current is 3i.
Okay, sir. Okay, sir. Okay.
Okay. Okay. So tell me any other thing that you can do. Yes, any other thing that we can think. Okay, fine. Let us see. So what we say, I don't have the exact value of resistance between these 2 points. Is that fine? I don't have the exact value of resistance between these 2 points, so I cannot apply that equation, which I was very comfortably applying, that I of t is I naught e raised to power minus t by tau, because I don't have tau. Okay, so then we say, okay, don't worry, we will take it as a normal circuit. Just a moment. Hello. हाँ जी बताइए.
मेरा वो मतलब कंप्लीट हुआ, जब टाइमर मैंने देखा नहीं, तो टाइमर खत्म होने के बाद फीडबैक लिंक ही नहीं था.
तो रीस्टार्ट करो कंप्यूटर. Okay. So now see, we are saying we can solve this circuit. See, what were we doing earlier? I had one resistor and one inductor. I applied KVL and I got the answer, right? If I can get my answer with one mesh, I can get my answer with two meshes also. Same thing, I will just repeat, I will make the process slightly longer, that is nothing else. So I take, this is my current 1, current 2, apply KVL. In current 1, in mesh number 1, what is the what is the drop across 2 ohm? 2 into I1 minus I2. What is the drop across this? LdI by dt. Okay, 1 by 2 di1 by dt plus 2 times I1 minus I2 equal to 0. And what will be the KVL for loop number 2? Hello. Okay. So what will be this one? This voltage drop is minus 3I. Okay. So this is actually first one, di1, this one we write it, and for loop 2, 4 times I2 plus 2 times I2 minus I1 minus 3I equal to 0. Okay. What is I?
Excuse
हाँ
me, sir.
बताइए.
So sorry
Yes.
to interrupt, sir. In loop number 1, sir, why we are not considering the sign like for the inductor? If we consider the above part as plus and the below part as minus, the terminals, sir, as we proved earlier that if it is entering, then the positive symbol, then we will write the drop as plus. So why we not concerned of that sign convention?
Okay. See, across inductor, anywhere is it given that whether this is plus or this is plus?
No, sir, it's not given.
So then conveniently we can assume our own direction, right? Okay.
Okay, sir.
Right.
Yes,
Same
sir. Sir,
now.
but in register it will be opposite.
Why? See, when I went there, the first question here, I said I am assuming this is VL, this is VR. If I make this and this assumption, that is also fine.
Sir, means if we are assuming this, then the sign will be same.
Yes. Only difference will come that VL and I relation will have a negative sign because I am assuming in the opposite direction. Okay.
Okay, sir. Okay, thank you, sir.
Now, coming to mesh number 2, the drop across this voltage source is 3 times I2, sorry, 3I. The drop across this is 3I. And what is I? I is this current, and this current is I1. Okay, so this is 3 times I1. So I get equation number 1 and equation number 2. Equation number 2 says I2 is 5 by 6 of I1. Replace this into this. Replace the
Excuse me,
value.
sir.
Yes.
Sir, in the loop 2, which loop are you taking, sir?
Loop 2 is this one. So drop is 4 times
So
I2.
here, sir, how we have written this equation?
Okay.
6I2 minus 2I1 minus
Fine.
3I1.
Fine. So 4 times I2 plus 2 times I2 minus I1 minus
Okay.
minus 3I1 equal to 0. Is it
Yeah,
okay?
I1. Okay.
Now you just,
Yes, sir.
is it okay? So
Sir, minus 3I1.
I1
So
because this
minus
is I. No, see, this is not I1, this is not I2, this is I. This is 3 times I. And what is I? I is the current here, which is I1.
okay, sir.
Is it okay?
Okay.
So now
Okay,
I
sir.
replace this I2 with 5 by 6 I1, and I come back to this equation, and this equation is this. Now I will restructure it in the form of di1 by I1. Again, do the same thing. Integrate, natural log, exponential. So this is the equation I got for I1. I1 of t is equal to 10 into e raised to power minus 2 by 3t. Okay. And I1 is equal to I. Is that okay? Then I can also say this is my equation for I. Am I asking anything else? I am asking Ix. What is Ix? Tell me. Ix is I2 minus I1.
I2 minus I1.
What is I2? 5 by 6
5 by
I1.
6 I1.
Okay.
5
So
by 6.
then you get those values also, right? And if I ask you any other thing like voltage across inductor, voltage across this resistor, voltage across that resistor, all those can you calculate now?
Yes, sir.
Okay.
Yes, sir.
Okay. Right. So this is
Yes.
how basically we solve the circuit if we don't get the direct formula fitting in my circuit. Okay. This is the last question that we have, and you can note it down, note down the answer also. Cross check if this is working fine, and from here we'll start in the next lecture. Tomorrow there is no holiday, no lecture cancelled. Some of you were asking, so there is no such thing. Okay.
Sir?
Yes.
Sir, the 3-hour lab class, which would be on 16th of December,
Okay.
what would we be doing like? There would be a quiz or something or
No,
assignments?
you will be shown that how to use softwares to make these kind of circuits, and then how to run the simulation.
Sir,
Yes.
sir, tomorrow is only your class or all subjects class?
There is no class cancelled for tomorrow until the respective instructor is saying that it is cancelled.
Okay, sir. Sir, no, tomorrow is Wednesday, sir. Basically.
Tomorrow is Wednesday. Tomorrow is Tuesday.
Okay, sir. Sorry, sorry. I
Bro,
am
what are you
confused.
doing, man?
Okay then. So please note down this and practice it and verify. We'll meet tomorrow. Okay.